story of trigonometry. Hello. So we're going to be dealing with new chapter, and last time we started that new chapter. So today, I guess, we're going to continue. It's the first section of chapter 7, discussed a little bit, and then I guess I want to, well, as usual, refresh and get some more here. So section 7.1 looks like we only worked with inverse sine function, and I guess the key idea is here on the figure 2. So they have a graph of a function called arcsine that could be used for visualizing restriction of a domain and the range of that function. So that's arcsine, or sine inverse of x, that is restricted from negative to positive 1 in its domain, and from negative pi over 2 to positive pi over 2 on its range. So I guess I put minus a little bit better visible format so nobody feels uncertain. So negative pi over 2 is here. And that's the, I guess, key idea of the section. Now we also had intuitive ideas for a definition of this function, and the intuition is the actual fact that arcsine is angle that has this particular value of function sine. So what this means, I guess the best way to illustrate is to actually do the exercise. So let me find one that we did not do. Is there such a one existent? I'm not sure, so maybe I'll just try 24. So this is finding arcsine for the negative square root of 2 over 2. Well, so I need to decide what angle has sine equal to negative square root 2 over 2. So that's what I have to decide. So sine of what angle? And that's how we work out pretty much every exercise in here. So to recall that square root 2 over 2 deals with 45 degrees, which we actually call as a pi over 4, and the negative square root 2 over 2, since we're dealing with a function sine, which means we're dealing with y coordinate of a point on the half of a unit circle. So we only consider the half of it that varies from minus pi over 2 angle to plus pi over 2 angle, just like in the graph that we also had here, from minus to plus pi over 2, the result of function arcsine. And then I can see that we have to take this negative pi over 4, since it's 45 degrees analog that has both an x and y coordinate equal to square root 2 over 2. Some with negative, some with positive sign. And I guess if you don't feel comfortable with the picture that I just produced, then I will open another window and find this textbook again by Sylvan PDF. So first choice gives us a textbook in here. And what I need is to look at the last pages, right? So very last pages is what we care about because they have all of the formulas. So if I look at this last pages, then I'm going to see the circles and everything else. And there is some other stuff here, which is given us trig functions, sine, cosine, tangent, cotangent. And so they really like this summary, and I like it too, the library of functions. The only thing is they didn't put arc functions here for some reason. So, well, I guess that's what we can fix by just placing this on a piece of paper. I guess that's pretty much all it is. So I'm just browsing through this again. So just see secant, tangent, cotangent, but not arc functions. Okay, so there is a page with formulas, like a quadratic formula, so all this stuff that you, I'm sure, know already. If not, you can look at them. And then the reason why I opened this page is here. This page, this circle clearly shows the fact that for y equal to negative square root 2 over 2, so I just care about this angle, then we're going to use 315, in other words, 45 degrees with negative sign according to definition of arcsine function, which corresponds to negative pi over 4. So that supports the fact that I just produced on the left side here. I know it's messy, so I'm going to go back to where we were. So this circle at the end is actually utilized to answer the fact that angle is negative pi over 4. And that's really all we learned last time, that those arc functions, arcsine is actually the angle that I have to be careful with. I want to make sure angle is coming from this graph, so the angle is in between negative pi over 2 and positive pi over 2, according to picture. So function arc sine has a friend function arc cosine. And this function arc cosine, of course, is here as well. And its graph is nicely provided for us also. So arc cosine, analogously, function arc sine is also giving us angle. And of course, the domain is same for all, but the range is going to be a little bit different. The reason why is because of function cosine of x, which is here. So if you decide to take its inverse, then the inverse is going to look like that along the y-axis, but it's not a function. So same exact explanation as for the function arc sine. So there are more than one intersection. That's why we eliminate all that extra stuff. We just leave whatever makes it be a function. And that's a little blue piece. So if you look at this little blue piece, it starts here at point, actually should be, I should be careful just to intersect right in the middle. So be careful. That and so it starts again at the point 1 on the x-axis, but it also ranges from 0 to pi. So different range for function arc cosine of x. Again, it's all because of the idea that we want it to be function, so we can't take anything else, otherwise it's not going to be a function. And that's why, well, I guess these facts about range are important. And that's why I put these pictures here. So I guess today we can practice to take some more of values of function arc cosine now. So I just want to deal with arc cosine only. And of course, this could be done using a calculator, as we saw last time, but let me first do it by hand, and then we can put it in the calculator as well. So arc cosine, like an exercise number 23, could be found using favorite unit circle, because when you say, Alex, you have a graph here, but how can I use this graph above? Well, this graph has no use for other things that range that actually shows us it's from 0 to pi, and that's why I have it here. So if you take arc cosine of negative radical 3 over 2, analogously to my previous example, I have to find the angle. So what angle has a cosine equal to this negative 3 over 2? So using the same unit circle idea, you can recall that cosine is always on the y-axis, on the x-axis. So if it's negative 3 over 2, it's very, very close to negative 1 here. And that negative 3, square root 3 over 2, will have a angle that intersects with my unit circle, but now it's defined on the region from 0 to pi. See the difference? Now with our cosine, we are only getting positive angles from 0 to pi, which is fine. We can definitely take that one. And notice it deals with 30 degrees, but there'll be quite a few of those 30 degrees. Exactly, 5 of them. Very good. So there's 1, 2, 3, 4, 5. Absolutely. So it'll be clean this stuff. As you said, 5 of this pi's over 6's. And I'm glad that you don't put it in terms of degrees, but you put it in terms of radians. 5 pi's over 6. So I guess that's the use of this circle. And again, you can always support this by going to the actual picture on the back of your textbook. And once again, here's your 5 pi over 6, and here's your cosine, or its x coordinate. So yes, this unit circle does not give you arc functions, but we always have to go to its inverse. So if it's arc cosine, then I'm caring about cosine of that number, and angle 5 pi over 6, which is circled here, gives us that answer. So looks like, again, unit circle here, and that's what we are getting used to. And the last time I also introduced you with a way to get it using favorite scientific calculator, right? So if I do that, if I put this in a scientific calculator, first choice, Desmos, how do we use that one? Well, just put it in degree mode, remember? Because with radians, you're not gonna get a very clear results. Put it in degree mode, and for function arc cosine, you need to go to the functional menu here. So you go functions, and then here's arc cosine. Some people do it like that. Well, I don't mind, I guess. I don't have control how you do these problems, but I just want you to do them right. So what's the question here for the exercise 23? Arc cosine of square root 3 over 2 is a minus. So now I need to go back to the main menu to be able to enter this square root 3 over 2, right? So I click main. It jumps out of this parentheses for some reason. It's a little bit of inconvenience, but I guess not everything is perfect. So this calculator should, well, bring your number back in. And once you put arc cosine, see, I wasn't careful. Square root 3 has to be on the top. So we need to put square root 3, and then I need to get outside of the square root this way, and then over 2, because otherwise it's not really defined, of course. And then in degree mode, not in radian, but in degree mode, it gives you number of degrees that corresponds to this. So you have 30 5 times, which is indeed 150. And that's why I recommended using degree mode, because otherwise it would take you kind of hard time to see what it is, because the decimal, which is actually the same as if you decide to check what is 5 pi over 6, that's going to be exactly the same, but the calculator does not give it to you. But it does give you degrees clearly, and then you can convert it to radians. So it's still involved a little bit of work, of course. So it doesn't really give you the answer that clearly. But what I just did is alternative way to do this same exercise without any circles, just plug it in the calculator. In fact, you need to know it, since there are problems in the next group of exercises, let's say exercise 26, that you cannot possibly do without a calculator, because all we can deal with is just 30s, 60s, 90s, 45 degrees, 135s, all these multiples of 30s and 45s. But once you dealing with some other measure of angle, and most of them, of course, are going to be others, not just these special ones that we can deal with, well, then you have no choice but to use a calculator. So I can give you this arc cosine. So go to functions again, enter arc cosine, go back to main and put 0.6 parentheses. So you get some kind of number in terms of radians. Our answers are always in radians. I say, so where is pi and whatever? Well, if you want, you can always get this in degrees, so you get a better feeling. But I guess other than that, so it's like 53 something degrees. So there's some random number, and there's nothing really you can do with it because it's not, again, 30 or 60 or 45. So you just leave the answer like that and pure calculator exercise. So it doesn't matter. You get a arc sine to find or arc cosine. In fact, maybe I'll ask you something like that for the quiz today. I think it'd be a good practice, right? So let me maybe clean this a little bit and say a few more words about this story, because we also had done some problems from the next group of exercises. And then we'll maybe have a quiz on just plugging numbers in a calculator, which I hope you're gonna like. And again, I recommend you using this Desmos calculator. So let me share the link to it with everyone again. So copy and put this in the chat. So I think this is really very nice calculator. But again, if you like some other one, it's fine with me. You can use whatever calculator you prefer, because I don't benefit from this company in any way. Plus, it's free. So anyways, let me try problem like number 42 that deals with the inverse functional story. So what's so special about problem 42, and why did I select it? Well, maybe I was in a hurry. Maybe I'll do 37 first, and then I'll do 42, because I think it's better to start with something more straightforward. So if you take arc cosine of angle, they are inverse functions. So inverse functions, they should return you back to where you started. In other words, they should give you back that 4 pi over 5. And indeed, if you look at the angle 4 pi over 5, which is going to be someplace here, it's in the range. So everything will be fine. And even if you put this in your calculator, yes, again, you can put this in a calculator, but with this pi over 5, I recommend degree mode. So let me do this for you here. So I put functions and then arc cosine. Now I need to go back to the main, so I can enter cosine here, right? And then 4 pi divided by 5, parentheses. You will see something not very nice, I guess, in degree mode either. See, it gives in degree mode and in the radian mode the same exact thing. That's kind of odd. I think that's the part that calculator is not doing right, because actually 4 pi over 5, the angle of it, if you want to graph it real quick, then if you take pi over 5, this is going to be like dividing into 5 pieces, right? Should be symmetric. So if I divide 180 by 5, it's actually 36 degrees. So if I take 4 times 36 degrees, there'll be a 120, and that's 144 degrees. So the answer it gives me is not correct because it's in the radians. But when I look at this, click degrees, it still stays the same. The others change, but I thought it'll give you in degrees, whatever it is, 144, but it doesn't. See, this issue of program in this calculator. People say artificial intelligence. It's just what's in the head of that computer programmer. So didn't work hard enough, and there you go. Mistake. So same thing happens, but they keep on improving these things. Messages don't try to completely rely on these tools. You really want to make sure that you are the one who actually does all the thinking and gives final answers. So anyways, if I go back to the exercise I was about to do, number 42, if you look at the range of function arc cosine, well, you're gonna see that this value, this negative angle 5 pi over 3 is out of range. So what needs to be done? Well, picture of unit circle, that's pretty much everything I do, all the problems we do in this class. Here we're using the picture of unit circle. So 42 with arc cosine applying to cosine of this negative 5 pi over 3 is not gonna work. In other words, it's not equal to negative 5 pi over 3. So it will be something with pi over 3, but not negative. How do I determine? Well, make a picture of 5 pi over 3 with a negative sign here. Oh, you're with us. Don't be sorry. I'm glad that you made it in spite of everything. You made it, and that counts. So anyways, 6 pi over 3 is going to be a full rotation. So I just take angle pi over 3, right? So you take angle pi over 3, and if you decide to get so-called caterminal angle, if you still remember that name, so the starting and the ending sides are the same, but you go the opposite direction, for example, so that would be negative 5 pi over 3. And that's the key idea here. So if you have angle out of range, well, get its coterminal angle that is in the range. And the range of arc cosine is from 0 to pi. So negative is not there, but pi over 3 is here. So we didn't really get that same thing. We got angle that ends at the same point, but it had to be a positive in between of 0 and pi. So this is really the idea. Analogous with exercise 40, with a sign of 3 pi over 7, is that with negative sign? Is that going to be within the range? I think so, because notice that 3 pi over 7 is going to be less than pi over 2. When you say, how did you know that? Well, you can put it in the calculator. I just know that if numerator here is like less than a half of denominator, so because if it's exactly a half, then we have pi over 2. But if that's 3/7, it's less than a half. So it's within the range. So for that one, it stays the same, negative 3 pi over 6. There are more exercises here that deal with this arctangent. I guess I will consider it next time, so I don't want to get into arctangent story much. But I want you to find answer for number 29 for a little quiz for today. So quiz, where can I write it here? Quiz, analogous, as I promised, to problem that I just did for you. What I did was number 26. How I did it? I plugged it in the calculator. And that's what they say, use a calculator. So I want you to just practice, use your calculator to get value of arc cosine. And once again, if you just came in and don't have access to the calculator, I will give it to you, no problem. So here it is. I just shared again the link with everyone. So click on that Desmos and again put that arc cosine of 7/8, and whatever comes out will be your quiz answer. And that's all we need for today. So after you're done with that, you can definitely relax a little bit. Right?